Hello, I'm Professor Rao, and here to give you an overview of this week's Module 11. Module 11 only has one chapter, which is Chapter 15, and so the topic is going to be products and processes. So products and processes are used to make them are continuously being redesigned to create products that are more appealing to customers, or even to improve the productivity, or even to make the products and their associated processes, more environmentally friendly. So producers kind of follow some well-established principles for product development. And these powerful principles include simplification, standardization, and specialization. Now, these three methods are aimed at making the product more reliable. So let's take a deeper dive into this. So, with information that's easy to share in today's environment, product design and product processes can work simultaneously so we can bring about better quality products to the market faster and at a reduced cost. So, as the design of the product is being established, the process is also being designed based on the quality level that's desired, the ability of the process to react quickly to changes in the customer demand. That would be called flexibility. Thirdly, the volume of the demand and how much the customer wants to be involved in the production of that product. Now, depending on the volume, the decision may be made to buy that product rather than make it, or the decision could be to use one process rather than another. Now, this is best determined with the cost equalization point, CEP. The cost equalization point is what determines if the volume is what is the volume below which the low fixed cost and a high variable cost alternative is used. And if the cost equalization point is above which the company is feeling comfortable to invest in, then you can assume that there's high fixed costs and they're looking for a low variable cost alternative. Now, continuous process improvement is something we've touched upon in the earlier chapters. This is pretty much applicable to all processes when you're trying to make more cost-effective and competitive decisions. So it's done as an ongoing basis, not just when new products are introduced. So the continuous process improvement uses traditional tools of scientific methods in 6 steps. That's where you select, record, analyze, develop, implement, and maintain. So more of a hypothesis-based, a rigorous scientific approach where you have to go through each and every step. Now, all these steps have one thing in common. That is, there's the involvement of people in that. Now, you know, there's a now when we talk about product design, you can't get away without understanding product specification and product design. There's a difference between the two. Product specification is going to be more focused on its intended functions, measuring the performance criteria, all the technical details, dimensions, and the quality standards. So, product specifications is actually a communication tool between the different teams involved in product development, like design engineering and manufacturing. And so when you look at product specifications, you'll get information on the user's needs, the target market, and any potential constraints that have been detected. Product design, on the other side, is more focused on the visual appearance of the product, the user experience, and the interaction design of that product. So we're looking at product design, we're looking at elements like color schemes, the layout, the topography that's used on the brand label, even usability considerations. So usually product design is going to start off with creating a prototype or a mock-up so that you'll have a visual representation of the final product. Now, how does product design and product specification work together? It would be the case of a guiding development. The product specification is going to be the technical roadmap for the entire design process, and it ensures that the final product does meet all of the necessary requirements and functionalities. Collaboration is involved. Both the design team and the engineering team have to work together to interpret that product specification and translate it into a functional design as well as an aesthetically pleasing design. Quality control. By clearly defining those product specifications, you'll be able to detect some issues or any inconsistencies in the wording of what's in the contracts and address them early in development. Now, there is, so industrial design and mechanical engineering haven't always been friends. So it's actually, before it used to be anything with manufacturing was thought that it should be very technical and only limited to mechanical engineering. So over time, we've learned that there are, that it's always been a question, how do we marry design with engineering? Designers appreciate when engineers engage in the design activities and they ideate, co-create, and brainstorm because that technical perspective brings a different set of eyes to the problem that's vital in any product design project. And this also enables the engineering to take the lead in the shipping phase as well. Now, while both design and engineering involve creating solutions to problems, engineering is primarily focused on the technical feasibility of that solution, using scientific principles and calculations, while design focuses on aesthetics, usability, and user experience of the product. So they're really prioritizing how it looks and feels to the customer rather than the technical functionality. But both are important. We know that because if design was not important to consumers, then we'd all be driving the same exact car because we're only concerned with having a vehicle that goes from point A to point B. But we know that's not real. If you ever go to the stop, a stoplight, you look across, yes, you have all of these vehicles. They all do the same thing, point A to point B, but we want different colors. We want, different interiors. And that's where design has to marry, mechanical engineering there. So designers also state that they're reliant and, frankly, blown away by engineers' ability to be able to turn, ideas into reality, kind of magically transforming a concept that's on some sticky notes into a working feature. So the industry of product development and manufacturing can be extremely complicated, even for the most seasoned of warriors. If you're new to the industry, it's especially challenging to understand what people are talking about because design is not engineering, and engineering certainly is not design. And if you're starting the developing process for a product, that slight change in terminology could cost you thousands of dollars in the long run. So before we get into how that can happen, let's look at some of the differences between the two so you don't make that mistake. So, an industrial designer's role is to focus on the user experience, the aesthetics, the textures, and even the ergonomics of that product. So, industrial designers are going to spend their time planning and integrating these key aspects of the product by creating a two-dimensional sketch. Now, the reason for this is because it allows that designer to create, filter out, and even conceptualize multiple ideas, features, and problems in a short amount of time. So, an industrial designer's work and involvement heavily occurs in the beginning stages of product development for this very reason. The beginning process of a product development is crucial because it's going to allow you to evaluate multiple options or solutions at once and then kind of hone in on what key features are truly important. So a designer's mind is full of creativity and it works much differently from that of a mechanical engineer. Now, mechanical engineering, this is the branch of engineering dealing with the construction and the use of machines. An engineer works through the manufacture and the functional aspects of the product. They produce functional prototypes that are going to follow guidelines from coming from the original 2D concepts that your designers created. So when you're creating these functional 3D models, the engineers are going to make sure that every aspect of that product is going to be in line with the processes of machining and mass production in both small scale batches and large scale batches. So the simplest mistake of making a plastic part either too thick or too thin could result in a product failure. and thousands of dollars would be lost to remake that production tool or mole and then having to rework that 3D engineering model. So engineers value design as a discipline that it can actually, facilitate that space for ideation, creativity, and brainstorming in an organized way. They enjoy coming up with solutions collectively, and they get that reassurance that design can and will kind of carry the torch of the user's needs as a way to light the path of tricky product decisions. So on paper, design and engineering are a great match. And when things are good, they're really good. However, in all relationships, they're not always going to see eye to eye on each other. So the key differences between designers and engineering is first the focus. Engineering prioritizes technical aspects like calculations, materials, mechanics to ensure that those are functioning properly. Designers, they are going to prioritize the user's needs, the visual appeal, and those intuitive interactions. In terms of process, engineers approach things with a very rigorous analysis and mathematical modeling to solve those problems, while designers are more about creative brainstorming, prototype, looking at user surveys and feedback to kind of refine their solutions. In terms of evaluation criteria, engineers will evaluate a design based on its technical performance metrics like strength, efficiency, durability, cost. Designers are going to evaluate the product based on user satisfaction, the visual appeal, and the overall experience. So let me give you an example to kind of hone in on the concept here. So if you're an engineer and say we're designing a bridge, then if an engineer is going to approach designing a bridge by calculating the load bearing capacity, the material strength, and the optimal structural design. But a designer, if you ask them to design to make a bridge, they're going to create they're going to look at maybe a user-friendly interface for a mobile app to help locate that bridge. They may even help with picking out paint, color schemes, layout, anything with intuitive nature to it. So the key takeaway is that industrial designers typically focus on physical appearance, functionality, manufacturability of the product, though they are involved far more during the development cycle. And engineering designers focus on product functionality. Engineering, also take care of the formal and aesthetic aspects of that product. So now that you've understood how the importance and the significance of both of these roles, let's take a look at this concept called design for manufacturing. And so both design for manufacturing and design for assembly are product design processes that aim to reduce costs and improve efficiency. Now, design for manufacturing is all about looking at the entire manufacturing process. Design for assembly, as the name says, it focuses on the assembly process. So, design for manufacturing is going to be involved in the material selection, the machining, the testing. So, the goal is there to make a better product at a lower cost, and it involves designing parts, components, and products that are easy to manufacture. And it also involves, simplifying and optimizing and refining the product design. But if we talk about design for assembly, this is where your goal is to minimize the number of parts that are involved in assembly, minimize the time and the cost of assembly. And so you're going to be, if you're on the team for design for assembly, you'll be considering how those individual components fit together and how those assemblies can be done more user-friendly or efficiently. Okay, so you have that down. The next thing is in here, concurrent engineering and sequential engineering are two approaches to the design process. And so let's make a difference. We designers state that they're reliant on and so design is not just engineering, but engineering is also design, as I said before. And so these two processes are concurrent and sequential engineering, and we're going to and I'm going to make a differentiation between the two. here. So many businesses in engineering manufacturing industries strive for ways to develop products and technology more efficiently. A popular manufacturing method is called concurrent engineering. And concurrent engineering is going to allow different departments to work simultaneously on that project. Now, understanding how this approach works may help you to learn how to implement it in an engineering environment. So many companies adopt concurrent engineering has a potential solution to reduce the time that it takes to for product development to occur and reduce the time from development to the time that it hits the market. So through the first stages of implementing, this approach could be pretty challenging. The competitive advantage that concurrent engineering offers is usually the powerful incentive. As a long-term business strategy, concurrent engineering, minimizes the need for multiple design networks. Instead, it creates an environment that's conducive to developing products correctly the first time. So, concurrent engineering is also referred to as simultaneous engineering. It's a method of designing, developing products where different stages of that development are going to run simultaneously rather than one step at a time. So, designing can happen at the same time that you're doing inspections. Whereas previously, the approach to product development was, oh, there's no way. If we're still doing planning, until planning is done, no way can we think of start building up a potential prototype. And so it decreases the product time and also the time to market so that you have productivity. So the principle is that you want to encourage the principle behind concurrent engineering is that there's better collaboration amongst the different teams, departments, and disciplines, and so they're working on a single goal that's going to combine the intelligence and knowledge of cross-functional teams through some critical elements. And so now, that is the elements that, make concurrent engineering successful would be the people, because, during they're looking, they usually these teams are going to be they're not just people who are experts in one field, they will be people who have knowledge across two or three fields, which means that they can move, between teams. So if you're hiring or building project teams, you want to look for candidates that have the right skill set and also experience. One is that, you'll have people on there who are good at working on integrated teams. They're good at even, implementing goals across the organization. Now, in terms of processes, completing a project often, involves several processes or series of steps that the team has to follow to achieve that particular goal. And that could vary from everything from, the planning part, the troubleshooting. And so in concurrent engineering, implementing those efficient processes is vital to supporting that team's decision making and execution of daily tasks. And so workflow for information management, including managing any changes, sharing the data, controlling any unwieldy growth, are all part of what happens in a day. So if you look here, you'll see that sequential engineering is very much linear. And you can see that we start off, concept and the design has to be done even before you build a prototype. And it's like nothing is going to overlap. Concurrent engineering comes along and says, hey, we could save time if we have people who are, cross-functional teams and they work, they can work on things simultaneously and we can get the products to market quicker. So, sequential engineering here takes the opposite approach to concurrent engineering because it involved designing and implementing every stage linearly. Sequential engineering came about, after the Industrial Revolution with the introduction of assembly lines and task specialization. So in this engineering approach to product design, each team member is going to perform only one task or two before they pass that on to the next person on the assembly line. So it's even sequential engineering is called the over the wall approach. And that term came about because each person's work is handed over this hypothetical cubicle wall over to the next person. And so this methodology relies on tasks being performed sequentially. And so, but the problem here is that there's very little communication or collaboration between the teams. So the concept team would probably never have a conversation with the design team. The design team would never even be have anything to know about what's going on with prototyping. So there's not an exchange of ideas, and it creates stagnancy within the organization that way. So each stage of the development is process is carried out separately, and the next stage can't even start before the previous stage is finished. So therefore, there's only a one directional information flow. And it's not till the end of the chain that, finally, when you have a finished product in hand, that you say, oh, oops, we spent $1 million here and this thing doesn't even work. And that's where concurrent engineering is a little bit different. Since there is conversations and there's a day-to-day approach to discussing what are the errors, then the entire team, irrespective of what subsection is going on, they will be testing it before it goes to the final approach. And that's also going to save money because, if you've already put together like assembled a whole car together, only to find out, oops, this car doesn't even have a motor that runs. Pretty sad day there. Whereas if you knew that the people who were working on the motor side had some issues, and then the design team could come in and they could also kind of help to tinker with it, then, we would be able to have fixed that problem before it got to that situation there. So the primary advantage of this method is that with sequential flow engineering, it's going to make highly complex project easy to understand and track. This method has other advantages that you can identify underperformers. But for this method to work as intended, each person has to be given all the right deliverables and specification from the previous person, and they have to be able to perform their task exactly as required before they pass the work on. So the main takeaways here is that there are many ways that product development team members can and do interact with each other. The best way for those teams to interact with each other is through every step of the product development cycle, both early and often. And working together from the start and continuing to work throughout the entire project is going to get you a much better product in the short amount of time and for the lowest cost. Okay, so that is your introduction to this module. And so this module only has one chapter, so be sure to read that. See you next time.